Hello, everyone. Thanks for joining us for our next online talk as part of the Dance online talk series. Um, I'd like to give you a few updates from Dance. Especially with respect to the resources, we've been developing and upgrading our resources, and specifically Lightside. We've been working on making it faster. And the production version of Lightside, we're trying to Dockerize it. So as before, if you'd like to remain informed, just send me an email. The email information should be on our website, dance.cs.cmu.edu. Carolyn will now introduce our speaker for today.
I am extremely pleased to be able to introduce our speaker for today, Ulrich Hoppe. He is a leader in several different research communities, including learning analytics and computer-supported collaborative learning. And he has recently been elected both to the ISLS board, that's the International Society of the Learning Sciences, and also the computer-supported collaborative learning community. So he has a lot to share with us that's relevant for this dance community. And so we're very happy that he was willing to take this time to spend with us today. So now Shri will introduce his talk.
Today, Professor Ulrich Hoppe will be talking to us specifically about learning analytics, which I'm sure will be relevant both to the practitioners and the researchers in our audience. More specifically, he's going to be talking to us about combining different methodological variations of learning analytics. And without further ado, I'm going to let Ulrich Hoppe take the stage.
Yeah, thank you very much, Carolyn. Thank you very much, Shri, for this introduction and also for the invitation to talk in this space, virtual space. My greetings from Germany, so early evening time, sitting in my home office. So I think we would share the screen now, and so I would start the presentation. Is this okay?
Yes, everything looks good.
Oh, okay, perfect. So this is the title of my talk, Methods and Paradigms of Learning Analytics in Current Research. I mean, of course, our current research, I will give you examples from research in my group. And you see here the two logos. Collide is my group. It's Collaborative Learning in Intelligent Distributed Environments. Was founded under this name in '95, so has a quite long history already. We have been working on different types of what we in Europe particularly call technology-enhanced learning, including CSCL, including smart learning environments. And the other logo is a more recent thing. It's a graduate school financed by the German Science Foundation, DFG, and it is on user-centered social media. And a lot of what we are doing in this area now is really connected to this graduate school. So this is, again, just the Collide group. And you see where we are. We are close to Netherlands in northwestern Germany. We have a department of computer science and applied cognitive science. We have 12 professorships in computer science and 4 professorships in cognitive science. Namely, these colleagues are from psychology. So we are an interdisciplinary department, and our graduate school is also interdisciplinary in this sense. So this is the page of the graduate school, started in October 2015. We have 24 scholars, PhD students, and 11 PIs with these different backgrounds. My background is computer science. And so I'm representing computer science. And when Carolyn said that I have recently been elected as a representative of the CSCL community for the steering group and also for ISLS, for the Society of the Learning Sciences, I do that as a computer scientist, and I feel I'm first a computer scientist and second a learning scientist. Learning science is my application field, and computer science is the background. And this is also important for the talk. I really want to show you some computational methods that I feel are of real interest also from a computer science perspective, and I hope you can share that. So this is, again, about the graduate school, the different perspectives that we take on the user, modeling and understanding user behavior, on the crowd, this is particularly the analytics part, and on the system, so the more engineering part of this. Okay, so this for the background. Now let's jump into learning analytics. I like to kind of represent the different ingredients of learning analytics computational methods in this picture of a trinity. So 3 different types of computational methods. The first one here is activity analysis. So when you focus on activity, means you try to understand processes going on in learning environments. You analyze sequences of actions from log files. You might use methods like process mining, and you're after the detection of action patterns or plans. There is a tradition, for instance, in artificial intelligence, of plan recognition or the induction of plans. So this has quite a long history, but it still applies here, activity analysis. Then we have the analysis of artifacts. In our modern educational environments, we assume we have learner-generated content. So it would make a lot of sense to look at the products generated by the learners and analyze these products using information mining, text mining techniques. Of course, text mining is of particular importance here because we can do a lot and quite easily with texts, as, for instance, the analysis of physical appearance in videos or so, which is, of course, more difficult. We have used characterizations based on, for instance, the semantic richness of such artifacts, and you can combine these kinds of analyses with, again, with user input by including user-generated tags and analytics related to these tags. The third level would be the network analysis, where you look at actor-artifact or actor-actor social relations. Many people know about social networks, but indeed it's not necessarily all about actor-actor social relations, but actor-artifact relations can be very interesting too. You will see examples of that, and then we have the typical measures that you get from the networks, centrality measures that give us cohesive subgroups, so parts of a network that are more densely connected than the rest. What I always try to make clear here, when you compare network analysis to activity analysis, network analysis does not have an inherent notion of time once you are in one network. If you generate a network, you collapse the data over a time window, and a link in the network will usually not tell you about time sequencing. There are types of networks that have a notion of time. For instance, if you look at citation graphs. Citation graphs have an inherent notion of time because a citation that comes from paper A to paper B means that paper A will be more recent than paper A. So this is the logic of these relations. But in general, these networks do not come with time. If you want time, this is a very interesting research challenge. You have to look at time series of networks, or you have to look at attributes of links. These are different possibilities how you can try to handle that. Okay, So as Carolyn mentioned, I'm on the one hand very much interested nowadays in learning analytics, but I'm also interested in computer-supported collaborative learning. And here is a number of current research challenges that I see as being very important, kind of hot and trendy topics in the field. And I've seen a couple of papers coming up in recent years on these topics. For instance, small group formation in big online learning communities is an interesting issue. We have MOOCs. MOOCs are big communities of learners, um, but usually based on anonymity. You don't know the others. On the other hand, you can form small learning groups that interconnect, that interrelate, and you can draw on the profiles that you have of the learners using algorithmic approaches to form groups that supposedly should create better conditions for learning, based, for instance, on heterogeneity. There is this old discussion, heterogeneous versus homogeneous learning groups. For instance, looking for the assumed knowledge levels of the students, or we have been more recently not just looking at knowledge levels, but more at the diversity of knowledge represented in the different students. Group formation is one thing, but the other thing would be also to scaffold the group work as it goes on. All this is currently, I think, very interesting. You can look at the evolution of ideas in knowledge building communities using network analytic techniques such as main path analysis. What you all will have seen is the customized design of analytics tools for different stakeholder groups, including particularly the teachers and tutors. So dashboards of different types. This is something that I will not go into because I assume this is really very well known, maybe the best known part of learning analytics research. But it does usually not go too deeply into computational methods, and this is what I'm interested in. So I'm really interested in the adoption of more advanced algorithmic approaches, particularly based on network analysis techniques in this context. Okay, now we will see two cases, two examples of our work. The first case study comes from a European project that was finished a bit more than a year ago. The name is JuxtaLearn, and you will find in the materials the references to the papers originating from this project. So the EU project JuxtaLearn was a project with partners from several European countries. It was coordinated by the Open University Milton Keynes, and it was a kind of inquiry learning in science. We have seen many science inquiry learning projects, so it was about STEM learning, but I like to call this second order inquiry learning because JuxtaLearn is based on the idea that you would learn from making your own videos, which requires that you have a basic understanding of a domain. And then the hope is that the students would kind of deepen their knowledge and their understanding of the domain by generating their own videos. And there is a process that structures the making of the videos. First, the conception of the videos, the making of the videos, the sharing of the videos, and the discussion of the videos in a community. So when I say videos, what do I mean here? We have seen different types of videos in an educational context. We have these lecture-style videos that you find on Khan Academy. I also do that in my own teaching, so I like it, but this is not what we mean here. We also have documentations, for instance, filmed reports of experiments, or also animation simulations. And we may have dramatized videos in which we combine the video with storytelling. And this is indeed what we did in JuxtaLearn. So videos combined with storytelling. So there is a narrative and creative element here. And you will see some examples of this. Our point here in JuxtaLearn that we want to look at, and that we represented with my group in the JuxtaLearn project, was applying analytics to these activities of learning through video making and learning through video sharing, learning through commenting of videos. So we wanted to look at the activities, we wanted to look at the objects in the sense that I have explained before. And of course, always with this typical idea of learning analytics, that you want to serve the perspective of different stakeholders. Researchers, teachers. Researchers might get better insight into the patterns of learning. Teachers might want to monitor the learning processes, and the students would receive video recommendations or recommendations also of the peer products. Their peers would produce videos that they would should look at and should comment on, and the system would try to direct them to videos that should be of their interest. So there was a kind of recommending mechanism also inside. This is a more elaborate view of the whole JuxtaLearn process, and you see here how analytics interferes with different parts of the JuxtaLearn process from the beginning. With the JuxtaLearn environment has a notion of concepts, of the basic concepts of a given domain, so a kind of taxonomy, or you could call it an ontology, but more modestly, let's say a taxonomy. Here already you can use analytics results to check the taxonomy. You can use analytics for profiling, for recommendation of resources, etc. I don't want to go into all the details here. The first approach that we used for our analytics was targeting user-generated artifacts, textual artifacts, and we used network text analysis, a technique that allows you to generate networks from texts. I mean, if I tell you this here, at least the local people in Pittsburgh should know about it. Work by Kathleen Carley and others. They have suggested this technique of network text analysis with an original tool set of AutoMap for the analysis and Aura for the network visualization. The interesting part of this network text analysis, I think from a perspective of computational linguistics, you would call that a very simple processing technique. Don't know if Carolyn would also see it in this way, but the interesting part is it uses a sliding window approach. So it's not only does not only give you a bag of words understanding or analysis of the texts, but it represents proximity in a sequence of words. So, and for the visualization, and resulting from a dictionary with multiple categories that you can use, you would possibly get not only networks of words in one general category, concepts with concepts, but you may have networks that connect certain types of concepts with other certain types of concepts and their relation to other types of concepts. For instance, you may have domain concepts related to people, or domain concepts related to locations, and using such categories, which is really interesting. We did a first application of the technique in the initial phase of the project when we analyzed transcripts from student-teacher workshops. These were flipped classroom-style workshops in which the students exposed and the teachers entered the discussion afterwards. And what you see here is such a network in which you have the domain concepts as pentagons. For instance, here you see diffusion, here you see carrier protein in biology. The squares are the user, so you have a person concept relationship. The gray links are concept links. You can also have them. And the blue links are the person concept links. So what you see here is, for instance, that student S5 has been very active. He is related to a high number of concepts, particularly in physics, but he also bridges over to chemistry. So this is the kind of picture that you get from applying network text analysis here. And this was useful, particularly also to kind of corroborate our understanding of the domain taxonomy in terms of the student's mental model. So we would see here if the student's mental models are kind of compatible with the taxonomy that we had provided the system with. We found then, and this was really an exploratory process, that we had certain concepts that would appear like help, explain, or difference between, that are not themselves domain concepts, but that were kind of signals of interesting things going on. So if you have terms like help, explain, or tell me about the difference between diffusion and osmosis, this is an indicator of problems of understanding on the part of the students, and we have further explored particularly this aspect. In the beginning, when we did not have material from our environment already, we have indeed been looking into Khan Academy. Khan Academy, as I said, doesn't have these narrative dramatized videos. It's this classical lecture style videos, but Khan Academy has very rich comments. So we have used the Khan Academy comments. You have the distinction between question and answers, and you have these moderated comments that are really high quality. You find the same videos usually also on YouTube, but if you look at these comments, they are relatively poor if you compare to the Khan Academy comments. We had several samples that we looked at, just videos, single videos from chemistry, biology, and physics that had quite large quantities of users, questions, and answers. So these were the examples that we have been looking at in a first study. And here you see such a result of applying network text analysis to such an example. And here you see links between pentagons, domain concepts again, and now squares, signal concepts. Here you see, for instance, the difference between the signal concept difference between connects, for instance, diffusion, osmosis, or solution active transport. In this representation, it is not clear which really were the pairs that appeared in the texts. But this was doable, feasible, with the original version of the AutoMap and Aura toolset. We have then gone into that and differentiated it. So this is now another analysis inspired by AutoMap Aura that we did. And here we introduced intermediate nodes, combination nodes. Here you see, for instance, here is osmosis, here is diffusion, and here you see that there is a link, a combination node between the two, and the size of the combination node will also tell you how often this combination appeared in the comments. So you see it appeared quite frequently. Other things from other videos that we found, for instance, mass and weight in the physics domain was a distinction, always related to the signal concept difference between, which is a kind of binary signal concept. And you see how often this appeared. Okay, you can project that back to the original context, so you see where these terms appeared, and you see the instances, the sources of this. Okay, so far this was using external material. We call that the external analytics part. This is now an example of applying this analysis to actual trials from JuxtaLearn. This was with our Swedish partners, a freshman seminar on scientific method. And here the students are generating their videos. Meanwhile, we had a platform called Clipit, produced by our Spanish partner, University Rey Juan Carlos in Madrid. And here you see you have the typical functionality of uploading, sharing, commenting, tagging, rating your videos. Now we had these videos from the Swedish trials. And now when you have such discussions of videos, a question that always appears, and it is crucial for the JuxtaLearn approach, would be how much of the discussion is really related to domain issues and how much is just related to the video making. It's not that we would like to exclude discussions that are more related to the video making, but of course, our main goal is to facilitate the learning, the enrichment of your understanding of the domain. So if we would see too much just video-related talk, that would not be so good. So we have some descriptive statistics on this, but we have also looked into the networks. And particularly, we have looked at cohesive clusters between users and concepts based on a method called modularity clustering. So we have looked not just at clusters of users talking to other users, but users mentioning certain concepts in their talk about the videos. We have mapped that to our web-based analytics workbench. Here you see that we upload. First, we upload the comment files with user information and the texts, and then we calculate first the degree centrality of users and also of textual concepts. And then we have used a filter because the networks that we get here would be very dense and complex. And here comes the bipartite modularity. And then here we have a table representation. Here we have a graph representation. And here we see the graph. It is a bit difficult to grasp, but I can tell you a bit how this graph is structured. The version that you see here has been hand structured by me. Meanwhile, we have based on a master thesis, we have an automatic layouting for such graphs. So in this graph, you see in the periphery the concepts. The color indicates the cluster. The shape indicates the type of concept. The diamond shapes are related to the video-related concepts, and the circular shapes are contents. So here about scientific method. This is about qualitative and quantitative methods. This is about measures, validity, and here you see the diamond-shaped concepts may be text, video quality, PowerPoint slide, etc. In the middle, you see the user clusters. But these are bipartite clusters. The blue users are connected to the blue concepts, the red users are connected to the red concepts, etc. Now, we can try to characterize these clusters. And this is what we have done. We have 4 clusters given by our modularity analysis. The red cluster has 5 users. here you see the number of video concepts, the number of domain concepts, and we have introduced a productivity ratio where we sum up the concepts, here 16 for video and domain, and divide this number by the number of users involved. So this cluster has been quite productive, 3.2. This one has 8 users, more video concepts than domain concepts, productivity 1.25. The biggest one is the orange one, has 14 users, has 9 video concepts, 3 domain concepts, productivity only of 0.86. And a very specific cluster is one here with 3 users, indeed dominated by 1 user. We can just switch back to this. This is the green cluster, and here you see this. The shape indicates again centrality, or a number of occurrences around this user, very much dominated by 1 user, and clearly focused more on video concepts than on domain concepts, high productivity. Now, if we look at that, we would say the red cluster is the best cluster. It has a good balance of video and domain talk. And also, if you look at the contributions of the users, it's a more balanced contribution of the users. So this is what you can get by this kind of analysis. The technology behind for rendering these networks and doing these kinds of analysis is our workbench. It uses a pipes and filters approach. Filters are agents, and they can encapsulate scripts written in different languages. Currently, we mostly use R scripts, but we have also used Python scripts or JavaScript. And the general architecture and the backend is written in Java, and it uses tuple spaces as a middleware for information sharing. It has a web interface, and so you can build up your workflows, and you can share the workflows, and you get your visualizations all in your browser. So this is a tool that we have used in a number of applications. Okay, you will also see this tool in the second case study, but maybe at this point, are there questions so far that you may have raised?
The only question I see is about whether the analytics workbench was available for public use or not, and you just answered that. So
yeah, it is available. I mean, it's you can just go there. We have several versions of it. For instance, these filters, as we call them, they can be quite this is a quite complex palette of options, and depending on the applications, we have customized versions. If you want to use it, it would be good to tell us, and we would help you to get the version that would best suit your application requirements. Okay.
I have a quick question. So I was really interested in your insights as somebody who's familiar with different ways of processing text, and you've chosen one particular method to be able to kind of get a, let's call it a shallow sort of estimate of, you know, themes and topics that you find in the text. And you pointed out really interesting about this technique is that it's able to leverage kind of the local properties of a text, so that you know kind of what words are close to it. And it's also an idea that in some kind of more recent techniques has been built in, like word2vec. And what I wonder is kind of to what extent have you challenged the interpretation that you get from these quote unquote shallow approaches? And what are the trade-offs that you see? Do you find that the variety of different approaches, LDA, word2vec, you know, what you're using, and other techniques, are they more or less the same? Do they pick up on different things? You know, are you more or less happy with the summary that you get about the topics? You know, so what can you say about what are the big opportunities there,
Yeah.
or are you just mainly satisfied?
I mean, these methods have their specificities, and the big advantage of, I would even say that the network text analysis approach is so simple, and yeah, you could call it shallow, is to some extent an advantage as long as it gives you interesting insights. And the interesting insights that you get are, first, that it's beyond a bag of words approach, and that it allows for these multi-mode networks. And multi-mode networks are very rich. We will see that now also in the second example when you apply network analysis techniques. We have used other techniques too. We have used LDA. That would be a different story. Very briefly, maybe, we used LDA in a context that was about detecting innovative concepts in certain, that was not in a learning context, but in a context of publications and publication networks. And we found that LDA was a bit too fuzzy, too blurry, if you wanted really to pinpoint something very sharply. Yeah, but this is the nature of LDA, that you have these distributions always that you compare. So for that application, we were not too happy, but our general approach is we have an API that we can mix into our also in the workbench that that connects to my colleague Thorsten Zesche's DK Pro toolset. You know that?
Yes.
Yeah, and so we can practically include DK Pro and whatever DK Pro encapsulates, including Stanford parser or dictionary-based things. That's another thing. Do you want just a standard general parsing of the text, or do you want to use dictionaries? For instance, the virtue of NTA comes very much with these dictionaries that allow you to do the multimode analytics. Yeah, so I think it's always a trade-off, and the point is we look for the richness that really resonates with the problem, and that is hard to tell just on a general level.
Okay, I'll save my other questions for after.
Okay.
There are two other questions from the audience. So the first one is from, both of them are from Borong Chen. The first question is, can you talk a little bit more about your use of Carly et al.'s dynamic network analysis toolkit?
I will come to dynamics in the second case study. So I would rather postpone that to this.
All right.
To this part of the talk to come. Yeah.
And the next,
because dynamics is of course a very interesting thing.
Yes. The next question is, can you also talk about specific measures of multimode networks that you found useful?
Yeah, and again, this I will take it up in the next example.
Okay.
So I have just had a look at the watch, so I think we should proceed. But yeah, I can really tell you that both points will be taken up in the second case study, and I'll go through it a bit more quickly, I guess. Yeah. So this is a case study that started with analysis of a small private online course. But indeed, the later version that you will see was extrapolated to a somewhat larger course that was more in MOOC style, although not really very big. I will tell you about the context. So if you have your courses that run on learning platforms, we use Moodle in my group. Also, my university uses mainly Moodle or whatever type of learning platform you use. So the point is that the primary activities are related to learners accessing the platform and getting access to resources on the platform, maybe creating artifacts on the platform, And so when we look at this material, we want to detect patterns of activity that allow us to characterize the learners and that would give us valuable insights into the learning processes. And again, I will show you how network analysis methods can be used here. And this is, of course, a very reduced space of relationships and entities. So what you have is are the typical log files. This is just an abstract view of a log database of a learning platform of any type. What you get here, so timestamps, users, actions, and the resources to which this is related, allows you to create, in first place, relations between users, learners, and resources. For instance, this is a video resource that has a certain name. This is a bipartite network. So we have students connected to learning resources. There is classical literature on such two-mode communities. This is an example from the famous Wassermann-Faust book on social network analysis. So you see, it's called social network analysis, but this is not just about social networks, but it's about so-called affiliation networks. This classical example is about users and events, gatherings between groups of users. Different techniques of analysis. A technique of analysis that we know very well from first unipartite networks is called clique percolation. Clique percolation is one of the techniques that allows you to identify what we call cohesive subgroups, sometimes also called communities, or I would rather call them sub-communities of a bigger community.
Professor, are you there?
Ulrich?